Hey everyone, this is Daniel for Rock the Code, and in this episode, my guest is Sam Newman. He's an engineer, a consultant, a conference speaker, and expert in the domain of microservices and distributed systems. He's the author of the books Building Microservices and Monolith to Microservices that have helped many companies make informed choices about their service architecture. And his forthcoming book is Building Resilient Distributed Systems, which focuses on the stability of software systems at scale. And in this conversation, we cover various aspects of service architecture, the evolving landscape of services in the age of AI, his writing work, and an underrated part of shipping quality software at scale, which is managing people, decision-making, and team leadership. I had a fascinating conversation, and I hope you'll enjoy it as much as I did. So please welcome Sam Newman. Sam, it's good to have you. Thank you so much for making the time.
Not at all. Very happy to be here.
All right. So you've done quite a lot of work in the microservices space. You've talked quite a lot about microservices, monoliths, and also the human part of that. But I wanted to start, while preparing this conversation, I landed on the worst of both worlds, which everybody agrees is the distributed monolith. And yet, there are a lot of teams and companies and products landing on this architecture. Why do you think that is? And do you see any steps or any tips to mitigate against that?
I think part of the reason we see it so often is that people see the benefits of distribution early and the pain of being a monolith later. I mean, there is obviously pain that comes with a distributed system, and people don't do this blindly, right? But they decide to distribute their application because it allows them to quickly scale the app, for example. Oh, great, we've got some more power. Great, we're doing well. And that's almost like an immediate dopamine hit almost. And it's only over time that you realize we may not have got the boundaries in the right place. And now we've got this big lump and we kind of can't change any of the pieces independently. And I think that realization often happens later. And almost by definition, when it's happened later, the problem's got worse. And now you're sort of stuck in this, as you point out, kind of the worst of both worlds. I would also be honest and say that, you know, having a distributed monolith is only a problem if you care about releasing software frequently. And that's really not been a concern, wasn't, like I say, a concern for most organizations 15 years ago. So I think what's happening now as well is over the last sort of 15 years, organizations are thinking we've got to ship software more quickly, right? When I first started, I started as a consultant when I was like in 2004. Most of my clients were releasing software every 18 months. They wouldn't care about distributed month. They do one big bang release every 18 months. And we worked really hard to get that down to 6 months, a month, a week, daily. And I think as well that the monolithic aspect of the software at scale starts to really hurt when you want to start doing small batch size releases frequently. And so I think that that sort of understanding maybe has come a bit more recently than I think we sometimes give it credit for.
I mean, this is a signal of the modern times, right? We ship software more quickly because there's lots to ship, and there are many requests from our customers. We have scale now. We have all sorts of different markets and different features, and obviously with AI, we can generate things very quickly now. So, kind of, it kind of takes for granted the fact that we have to ship frequently. What piece of it seems to me like what you're describing is a lack of awareness while imagining or while architecting the applications that eventually land on the distributed monolith. What bit of that lack of awareness do you think happens more frequently, and how do you think we can protect us against that?
I think there's still a general lack of understanding of structured programming. To put it in basic terms, I think people use the words of structured programming. They talk about coupling and cohesion, but they're often throwaway concepts. I don't think people really understand ideas like information hiding, for example. And so I think that people kind of don't understand necessarily. I'm making general statements here because I'm basing this on evidence. It's very rarely that I see those practices put into place on the code bases that I've worked on over the last 20 years or so. And that's often because, again, the payoff is longer term, and often we're short for time. I think the other mistake that happens within that is we see sort of the role of architecting as almost like a one and done activity. And so we often will have had a time when people took the time to think about the boundaries and the structure of our system. And maybe they set up that initial structure, but they don't recognize that that structure not only does it need to be maintained, but it needs to be changed as required. And so what happens is you lay down a structure and it either gets overgrown like a garden that hasn't been kept, and those boundaries and that nice structure gets kind of vanished. Or else what happens is that boundaries that you put in place are no longer fit for purpose because the system's now doing something different, or you're using it in a different way. And those structures become an impediment to you. And so a developer just punches through them, right? Uh, Going in and changing visibility. I mean, I'm going to hold my hands up now. And when I was, when my first job back in, would have been my first paying gig, I suppose would have been 97. And I was so excited when I found out that I could define a C macro that would redefine the private keyword as public, which meant I could break encapsulation, which made my life much easier for a very short space of time, right? So I've been there. So I think it's that double whammy of, the not knowing the fundamentals. And then also, if you do know the fundamentals, you sort of treat it as one and done. Whereas I think in actual fact, it needs to be like maintaining that structure and that order needs to be an ongoing part of your system design and evolution.
I have two follow-ups to that. One is for the subset of developers and teams that you say lack the fundamentals. What kind of fundamentals do you think that are really crucially important to master so that you can protect yourself against this not inevitable fate? And by this, I mean some principles that um, you would advise, for example, in a 2-week boot camp at the for all new hires in your company, saying you must read this and this.
Yeah.
No code will be shipped unless you have practiced this and this. What would the this and this be?
I, I think it's a bit interesting because I think if you're a developer just starting off, I don't necessarily expect you to know everything to put that structure down. That a fuller understanding of the benefits of structured programming and not something that I would expect a developer who's in their first year of their career to really understand. And I think if we are relying on them implementing and maintaining those structures, then I think we get what we deserve. But like when I point people at resources, say, if you want to know more, I try to distill down like just enough structured programming for microservices in the second chapter of my book, right? And I sort of pull together, I try and do a through line from structured programming concepts like coupling cohesion, so Constantine's law and those trade-offs, information hiding, how that all relates to domain-driven design. It's a single chapter you can read in like 20 minutes. If you want to go deeper into a lot of the texts around structured programming are quite old. I've got some from like the 60s, and when I need those books, I often have to email Kevlin because he's got them all, and I ask him for like photocopies and stuff. But I would also like as a book, I would really recommend Vlad Kononov's book on balancing coupling. There he talks a lot about the different types of coupling because there's multiple different types of coupling. And I always appreciate that. But that's also a great book because he goes through worked examples of that. He's actually doing some work at the moment, creating some skills for Claude so that Claude can help you, can help understand what your module structure wants to be so it doesn't break and violate that. And so I think that's kind of really useful work because, you know, we need our, we've got a lot of AI that's been trained on code that isn't necessarily well structured. So we might need to give it some hints and tips here and there.
I'm going to land on AI in a moment. Uh, will remember the bookmark that I left a minute ago, which was for the other people that you say know the fundamentals and yet they still land on the worst outcome. Why
Yeah.
do you think that is? Because, and I'm asking this because I've worked with very senior people, exceptionally smart, exceptionally knowledgeable, very well read, practice a lot of stuff, and yet bad things happen. Why do you think that is?
I think there are two potential reasons it can happen. One is that the world around these people is so crazy that they never have the point to stop the time to stop and reflect. So if you're constantly running around after fires and you don't have the luxury of time to stop and think about things. They're not doing this out of spite or because they don't think it's a good idea. They're doing it because they've got 55 other things on their plate, all of which are on fire. Now, some of those things might be on fire because of this issue. I think that's part of it. I think the other part of it is really about how long term or short term your thinking is. And I think this is like a really underrated aspect of sort of organizational team design is that teams which are long lived make better decisions around long-term technology. Now, if you're going to be working on a project, you're going to be there for 3 months, for 6 months. Even with the best will in the world, your kind of incentive structures, both kinds of extrinsic and intrinsic, are often going to be motivated around those short-term goals. Whereas if you're working as part of a team that's thinking, we are going to own this next month, in 6 months from now, a year from now, 2 years from now, then I think you make different types of trade-off decisions around that. You are much more likely in that environment to sacrifice a short term for something that's going to improve in the long term because just bit of human nature, you're also going to be getting the benefits from this. Anna Shipman used to be CTO at the Financial Times. I think she's now CTO at Kooth. She wrote a really great article about the benefits you see when you move to what she refers to as durable teams. And this has been discussions going on for years. I remember seeing Mary Poppendick talking about the importance of long-lived teams, probably about 10, 15 years ago now. And obviously that's kind of meant it's a part of the streamlined teams in team topologies. But long-lived teams outperform short-lived teams and they make better trade-off decisions. So I think, whereas if you're a senior technical leader and you're getting moved from project to project, you're jumping in here, you're jumping in there, you're doing this, you're putting out fires, you don't have the time or the headspace to do it. And you're only thinking about the short term. And so I think that's the kind of the third thing. I said there were two. The third thing I would say is some people, they might be really experienced, they may never have seen good before.
Right,
I mean,
because
that's a big part.
it also matters what kind of experienced you are. Because if you've been experienced just on a certain style of code, that's I mean, if you've only used a hammer in your life, you're gonna see everything as just a nail. Whereas there are a million other tools, there are a million other techniques, and so on and so forth. That's a fair point. Um, I'm going to cover AI in a moment, but I wanted to ask about your forthcoming book, which is Building Resilient Distributed Systems. Why this book and why now?
Why now? I'll answer that first. It's because it's late. I should have finished it about a year ago, Daniel, if I'm being honest with you. So it should have been why 2025. Um,
Even so, even why 2025?
yeah,
Because
but
the
like I
discussion around distributed systems and the resilience in distributed systems has been going on for a while. And I believe, especially with AI, which we're going to touch on a little bit later, it's becoming increasingly important. And I wanted to get your take on that.
so I mean, I wrote my book on microservices because the original book on microservices, because I thought it was kind of an interesting style of architecture and I wanted to explore the implications of that style of architecture. And I wrote a second edition of that because I learned more. Most of that second edition is about all the problems and pain points that come from microservices. It's mostly about these are all the terrible things that you're going to have to deal with because of your choices that you've made, right? And despite that, lots of people still thought that using microservices was a good idea. So I was sort of inspired in a way to write this book because, like, my son's a developer now. He got dropped on a project where people are using microservices. He's got no background in distributed systems. I mean, even people that go to uni at best have a theoretical working knowledge. So I sort of wanted this book to be a bit of a rubber ring that you could give to any poor developer that's been dropped on a distributed system project, has no idea what the hell's going on, right? It is a knowledge flotation device. And so for that reason, although there's text and distributed systems, I mean, But am I going to point most people at Tannenbaum? Yeah, it's a good read. There's good stuff in there, but it's a heavy read. There's books about site reliability engineering, right, which are very specific around that role and typically how Google does that role as well, right? And so what I wanted this to be a book that a developer who was working on a distributed system could read from beginning to end if they wanted to, but it's topic based to learn what are the fundamental things I need to do to make any distributed system more resilient. And so in that, it's not, it starts with sort of basic concepts like, how do you get a set a timeout? What should a timeout be? Idempotency, why circuit breakers might be terrible, all that sort of stuff. But I also talk about like the nature of resiliency. There's a whole world of resilience engineering, which is quite academic and can be quite opaque to people from outside of that world. And so what I wanted to try and do was to also take some of those concepts and make them a bit more palatable and sort of weave that through kind of quite practically oriented chapters, right? So that's the kind of been the goal.
How do you do that? I mean, how do you take these otherwise very hard concepts that are known to be academic, they're known to be hard to digest, they take many years to master properly. How do you make them more palatable, as you say?
Spend many years looking at them. I mean, literally, I got like really interested in this stuff back watch at the Velocity conference. I got to know John Allspaw a bit. This would have been, again, this is well over 10 years ago, and following some of the work from that area. And he would mention things here and there in his presentations. I'd go and try and read them, and I'd get back to John and say, John, this stuff is absolutely impenetrable. What is all this gobbledygook? And when I got a little bit of time with him here and there, and we're talking, he would sort of break it down, and then I'd spend time reading and hitting my head on it, and then reading lots of people and how they explain these concepts and these ideas. And so for me, like I didn't want to write this book until I felt like I'd broken the back of my own mental understanding around these concepts and tried to distill it down a little bit. And also trying to keep that persona in mind the whole way through. There is this sort of challenging thing whenever I mean, I know you find this, I'm sure you find this with your own work. It's like at the point where you're confident enough to teach or to share knowledge, you already know that thing inside out. So it can be easy to become detached from the person that's going to read it. So for me, having a bit of a sense of the persona in mind who might be reading that book was kind of useful to me, as trying to keep myself a little bit honest around that. And to also be honest, a big part of that that helps me a lot is having a good mix of people who are my technical reviewers. I've got somebody who's just an excellent developer and author. I've got somebody who really knows site reliability engineering. I've got someone that's a distributed systems expert. I've got another person that ran operations and is a copy editor. And, you know, that those people keep me a bit honest in terms of how I write and share and communicate. And I very much like doing that on a chapter by chapter basis. Like, and ironically, I like getting that fast feedback, right? It's how I like so code and how I write things as well. I mean, the other thing I do is I do a lot of online teaching for O'Reilly and things like that. And so I tend to write a book once I've already got a class or two in that area. So I'm going to a conference, I'm doing a talk, doing a workshop in person, doing a workshop online, and you get that feedback. You get the questions. That question comes up a lot. Maybe I haven't explained it well. And so I kind of, it's all of that stuff together. For me, it's just sort of, I've had to build that into how I do my work, really.
What do you think is very important for a developer working in distributed systems to really, really know about resiliency at the time that we're recording this in 2026 that
Uh,
has been, let's say, poorly covered so far?
I don't know that it's been poorly covered because I don't think there's anything new in my book, right? What I've tried to do is distill down stuff that's covered really well elsewhere, but people don't realize it. Okay, so let's be real. Let's start with basics. You can't pretend the network doesn't exist. You don't get to pretend that. That's just, it's there. So I kind of distill down like I have these sort of three golden rules for digital. These are the three golden rules you have to remember about any distributed system. And these are like fundamental truths, and you don't get to escape them, and you can't work around them. The first thing is you can't beam information between 2 points instantaneously. Can't do it. Second thing is sometimes the thing you want to talk to isn't there. And the third thing is that resource pools are not infinite. Stuff runs out. And like once those are, you can go through all the complexity of distributed systems and talking about Raft and Paxos and all this other stuff. But once you drill down at a fundamental level, that underpins all the complexity in and around like distributed systems. Those fundamentals, by the way, have never changed in computing from the moment we had our first distributed system. And so for that, that's always rolling around in the back of my head. The second thing about resiliency is a viewpoint that I think is really useful. And I think it was I originally got this from Eric Holnagel's work, which was, we originally had this kind of world of safety management. And that was kind of the view through which we looked at, especially safety critical systems, which was safety management was all about, we need to make sure nothing bad happens. Right, that's our goal. We need to make sure that nothing bad happens. What we've learned, of course, is that that's not really necessarily always achievable, and nor is it necessarily scalable, right? So when we take that resilience engineering viewpoint, we're saying, sure, we might want to try and stop bad things happening, but our main job is to make sure as many things go right as possible. And that's a slightly different way of thinking about the world, because a lot of people build systems to try and make sure that nothing goes wrong. But if something does go wrong, those systems collapse. They're not resilient, they're brittle. They don't bend. They don't have properties like graceful degradation of capabilities or anything else like that. They snap. So that mindset of making sure as many things go right as possible, I think is almost that other kind of pillar that runs through the book as well, which is, sure, let's try and limit the failures, but you've also got to know how to deal with it when they happen.
This is very interesting. And one theme that I noticed in your writing was that both in the work that you've done with the monoliths and the microservices, work that you've been doing for a while now, and as I was perusing the table of contents for the resilient distributed systems, you always seem to include the human aspect in the developing of the software, which is, I think, an under explored part in the writing of the software, because we tend to talk a lot about the code, about the properties of the code, about the products and whatnot, but less about the people developing that.
Yeah.
But you seem to find it very, very important. Why is that?
I think just because it is. I mean, I found that to be true, right? And
I mean,
I
it's a
realized,
tautology
yeah,
the way that I phrased it, but
yeah,
I'm
yeah,
pretty
yeah,
sure
yeah.
you
But
had some. I mean, you noticed things in your consulting work
yeah,
that made you specifically focus like a significant portion. I think it's like a quarter of the book, if not more, just on teams, on organizations, on human nature of things. Could you speak to that?
yeah. I think it probably started partly because of being a consultant. I'd done work before being a consultant, and there's a famous quote by a guy called Dre Weinberg, which is, "It's always a people problem." So when you come in and you look at a piece of code, you look at a piece of architecture, you think, well, that's why this problem is here. Well, let's fix it. But you have to recognize that that system is a product of the environment, product of the people working together. And so if you just fix the code or just fix the architecture, you come in and go out again. I was actually always much more interested in leaving lasting change. I don't think I was successful very often, but that's what I wanted to do. Then I got really interested in the DevOps movement, which was really all about culture more than anything else, although it got co-opted by tool vendors, right? That was all about, how do you get people to communicate and work better together, right? And then when I started going into the resilience engineering space, you realize actually people who study resilience engineering, they understand that the people and the social structures is more than half the problem. There's a term I expand on in the latest book, which is this concept called socio-technical systems. It's a very old idea, but but literally it describes a system where you've got people working with technology, and technology in the kind of more generic sense of being knowledge. I think the original work was done studying how coal miners work, right? And so if you are trying to think about the resiliency of a system, maybe a circuit breaker is part of the solution, sure. But being resilient also implies the ability to react to surprises, right? AI can't do that. And a lot of human beings, by the way, can't do that. A lot of organizational structures can't react to surprise. So, when we build our systems, and I sort of sometimes distinguish between robustness and resiliency. When we sort of make our systems more robust, and this is certainly how uh, David Woods talks about it, what we are doing is using our knowledge of what we know could go wrong and ensuring our system deals with the things that we know could go wrong. So that's making a system robust. So we know, for example, that a container can fail. So we use Kubernetes so that if a container fails, it gets replaced. Now, that's one aspect of it. What about the things we didn't expect? We can't know those things ahead of time. So how we deal with that surprise, that's a human factor. That's about individuals. That's about the environment. That's about making sure that we can react and change quickly. If you've got an organization with very specific role definitions, for example, where you cannot step outside of your box, you're going to find it very difficult to react to surprise because the organizational structure and the controls in that environment may stop you from doing that. You also need to have an environment where you can surface when things go wrong so that you can learn from that. A lot of organizations which are blame cultures where people won't tell you when they make a mistake. And because they don't tell you when they make a mistake, you're not aware that a mistake is even possible until it becomes a major issue. And then it's the people and the organization that then decide to take that knowledge and turn that into changing the system and changing themselves. And so, that's the kind of, so I think when it comes to looking truly at resilience engineering, I think the socio side of the socio-technical system is probably more than half the actual battle there.
Have you worked? I was assuming that while reading your work and while doing the research for this conversation, I assume that most of your work is mostly technical, and you're consulting about the technical bits, about how to organize the code, how to organize good practices around the deployment of software. Do you work with the teams themselves by any chance? Just
Yeah, I like to if I can. I think it often depends on why I'm being engaged. So quite a lot of my work nowadays is I'm working with people who are dealing with an architectural challenge. They're looking to maybe re-architect their system. They want a sense check on some decision making that's going to be done. And so for those kinds of activities, although I'm typically working with the people that are going to be making those decisions. And so I'm not working with the actual teams that are going to write the code as much. But there are other clients I've got where I've been working and supporting them for a few years. And so we have like regular calls. And one of my favorite clients in the US, most of my sessions are actually with effectively the CTO there. But there'll often be people in his team that want to grab me and want to talk about, want some of my time or this particular issue. And so I'll absolutely work with the team as well. I don't write production code anymore, except for my own Home Assistant setup, right? So I'm no good at writing code, but I still keep quite technical. So I'm very happy to have those conversations. I also think that there are lots of downsides to being a consultant. But if you've made a decision to bring one in, one of the benefits they can bring in is other viewpoints. And ideally, those viewpoints should be shared. Ideally, I do like to talk to the teams because they can ask me questions and I give people, honest answers, about those sorts of things. So wherever possible, that's absolutely something I try and do.
Do you also work with reorganizing the teams themselves if you see some organizational changes that need to be made in order for the software to go better? For example, the original question was about microservices, whereby if you want to split the team working on various services into sub teams, each with their own delegated things, or if and to what degree they should communicate, Do you also work with the teams to reorganize themselves? And can you give me an example? Because we've
Yeah, I mean, I don't do the actual kind of reorg piece myself anymore, but I have been involved with that several times. Quite a lot of the work I did at ThoughtWorks would have been what we'd often refer to as delivery through enablement. And so a company needed something built, but they also wanted to change the way they worked. And so as part of that, like you're working and the work I prefer doing, I would be on site, mostly pairing with developers. We're working code, we're shipping code together, and but while we're there, we're sort of changing practices, we're changing responsibilities. Um, and the place where I've seen that, so now when I talk to clients about that, I'm talking more big picture stuff, like we'll look at their org structure, I'll take a look, I'll take a look at the PR flows and all that sort of stuff and talk to teams and understand their challenges. And I can come up with some suggestions, but I'm not going to then be there and do the boots on the ground work. I mean, I remember that I still think that the approach where we sort of change responsibilities and to an extent structures most effectively was the work that I was involved with at The Guardian. Guardian newspaper in the UK. I was involved, I was one of the tech leads that helped rebuild the kind of digital side. And I can't take credit for how this work was set up, by the way. Most of the structure of this organization, this engagement set up by Eric Dernenberg and Matt Wall. But there they very much had an idea that they wanted to grow the responsibilities and the knowledge base of the team. And so they said, okay, well, these are the new skills and these are the new knowledges that we want our team to have. And then and then the way it worked is that each person in that team, they would self-assess where they were on these scales. And then they would say, where do I want to get to? And they would each have a buddy. And so literally, I would be buddy of like two or three developers, and we would talk, okay, so what are these skills do you want to be able to grow next? So like for them, for example, we'd pick some axes that were around the new technologies they're bringing, like because they're moving from like a TCL based system to a Java based system. So Java programming using Hibernate, Oracle stuff, and all this. You had a scale of 1 to 5, which is 1 you had no idea what it was. 5 was you could write a book. And so you'd go to someone and say, well, I think I'm a 2. And I might think, I think you're a 4. It doesn't matter. But they wanted to improve it. And so then it would be, okay, so what are the opportunities coming up in the next week, the next 2 weeks, next 4 weeks for you to grow that? And so that's the kind of stuff where, but that is you're folding in that skill growth into the normal part and normal flow of delivery. I think the reorganizational stuff I've been involved with also internally at ThoughtWorks. I was looking after our internal technology, all the sort of the software delivery part of that for a while, and we were shifting a lot of responsibilities around within that. And it was almost like you could list out, here's, post, and that's the exercise I still do with teams now. It's like you want to make a change. Let's put on a post-it note all the things that needs to happen as part of software delivery that you do right now. Like one thing per post. Like get people in the room, you throw it up. You can do it on Miro, right? Throw it all up. Okay. Now let's map those things to who does them. And that actually becomes a really interesting exercise. And because then you'd see that the developers had no idea how much work like the operations team would do or how much work the QA team would do. And you throw all these activities up and say, here's all the things you do. And then probably alongside that, doing something like a path production analysis. So showing them cycle time, showing them snags and all those things. And then you say, hey, that's where we are now. These are the responsibilities. These things they all need to be done. Can we automate some away? Okay, this is what we're left with. These things need to be done. So how do we move them? So if you're doing all these things right now, can one of those post-it notes going from the first line support team and actually maybe in the next 3 months, can we pull that into the development team? And then you're almost bringing those things in a piece at a time. Um, when you're going around reorganizing, there are other tricky issues that can come up. There's a lot of information in Sarah Wells's book, which is called Enabling Microservice Success. But like in some situations, for example, it involves talking to HR because people's employment contracts don't match the new org structure you want to come up with, right? I'm not a HR professional, right? So yeah, that's the kind of examples of stuff I've done before.
thank you. Really appreciate them. And it seems that in your work, a lot of the job of a good consultant means just to raise awareness and bring clarity into the way that software is being shipped and delivered, because there are a lot of parts in that, especially in large teams, that are being taken for granted, and they can cause friction if not addressed or not at least surfaced from time to time. I wanted
But,
to.
but but I also think it's also like it is that time thing that by the fact they brought a consultant in, there's a recognition that something needs to change. And that consultant is often given the time and the headspace to look at this problem in the way that the people on the ground haven't. I think the people on the ground could have done this and spotted this, but they haven't been given that time or that space to do it. And I think the answers are nearly always already there.
But you do need to know what questions to ask,
Yeah, that's
which
true. That's
brings
yeah.
uh, which brings me to uh, a little, uh, let's say, different direction. But it's well tied into what we've been discussing so far, which is how LLMs and the AI, in more, let's say, broader scope, impacts the decisions that people make in choosing architectures. What have you seen so far in this short time span that we've been adopting AIs for software? What decisions have been, uh, let's say, uh, considered best practice until Claude, and now
Yeah.
it's no longer best practice?
So I think there are working practices that we've got that are being put under more pressure because of good code generation. I think it's probably worth pulling back and saying that, much of the focus around LLM-based AI tools in the software delivery space really has focused on the easiest part, which is the code generation, um, which Microsoft reckon is about 11% of the work involved in shipping software, right? That's their own internal stat, right? So that's where most of the energy and the focus has gone on. It's also the thing that's easiest for the LLMs to deal with as well, right? Because they're very good at generating code because there's some translations. So, but what's been happening is that we're starting to see pressure placed on normal working practices that are suffering. So, I'm literally hosting a thing for everybody next week, and one of the talks we've got coming on is looking at what's happening around PR processes, for example. So, we know that the LLMs like writing bigger change sets, and it takes work to get them to write smaller change sets. We know when you write bigger change sets, people are not as likely to review them, right? If I send you a 10-line code commit, you're probably going to take time over looking over it, the 10 lines. You probably send me back a couple of comments. If I send you back 20,000 lines of code, you're going to go, yeah, that's fine. Right. It's those extreme examples. So that's problematic. I'm not talking about the open source world. But it's been really actually delightful for me. I'm starting to see organizations going, maybe we should ditch PRs and go to this weird thing called trunk-based development. Like I'm seeing people talking about that, which is fantastic for me because I think the PR process was fundamentally never suited to enterprise software development. It was designed for open source projects delivery, right? It's
That's
not
very interesting. I'm
designed.
going to leave a bookmark there because I wanted to
Yeah,
ask, but
yeah.
carry on.
But so I think that's been, I think we're working our way through that. I think the next stage we're at now is the verification side, which is how do we make sure that the code that's being written is good enough? And I think what we mean, and I like Kevlin's got has a nice kind of model of breaking down requirements sort of into three buckets, right? There's functional requirements. Does it do the thing functionally I want it to do? There's operational requirements, which is it fast enough? Is it, going to be robust enough? Is it going to be scalable? And then there's developer or development requirements, which talks more towards things like structured programming angles. I think we are relying on, to a large extent, on trying to improve context for the coding agents to try and get their code to fit in our development requirements. We're not really doing much validation as to whether it's actually doing that. We're around our functional verification. We're probably furthest along because we already are quite familiar with writing functional testing and having the AI generate those and checking those out. We're nowhere near the operational requirement verification side of things because it's a much harder problem to solve because it's also not a generic problem to solve either because what code looks like is fairly generic. What your system's operational requirements are is quite niche. And so training LLM on vast amounts of publicly available data isn't going to get there. So I think there's all that stuff to still be kind of unpicked. I have a lot of confidence that we'll get better around making sure the functional code we write works and getting better about fitting that into an architectural shape that we like. I think the operational requirement aspect of this, I think we're still a long way off, and it might not even be tractable with the technology we're using right now.
How? What kind of tools have you seen arise to tackle these challenges? I mean, I'm going to give an example from a programming language, like very down to the code level. You would like, for example, to have a strong type system or to have some sort of, if possible, formal verification, which is why all these languages are being developed. They have been developed for a while, but they become more and more relevant in this space. Whereas, for example, Lean and stuff, which do really proper mathematical proof. If it compiles like you know for a fact that it's correct. This is an example at the very low level, like the programming language level, when writing code. What tools that have a similar philosophy to this have you seen in the spaces that you're describing, which is like the functional verification, operational verification, and so on and so forth?
I mean, nothing that comes close to the formal verification you're talking about. I mean, I know enough about formal verification to know that I don't know enough. Like I spent like 3 semesters at uni doing this stuff and using things like SED and working out lambda calculus from first principles. We're nowhere near that stuff at this level, and I also not convinced it's a useful use of our time at the moment yet. At that level of detail you're referring to, right? I mean, yes, you can play around with TLA plus and stuff like that, and lots of people do, but it tends to be a niche activity. I think
What have
in
you
terms
landed
of,
on at the moment? What have you landed on at the moment?
um, honestly, I this actually it came to me as an epiphany. I was doing a panel the other day. Someone said, "What's the junior developers do if they can't get a job because no one's hiring for AI?" And I realized there's 2 things you should do: either become an SRE, which is quite difficult to do if you can't learn on the job, or become a really great technical QA. I actually think when we shifted testing left, we denigrated the role of really good QAs and we lost some of that skill set. And I mean, like proper good technical QAs. I think a lot of organizations didn't feel those people were required. And we looked down their noses at those people and we sort of said, yeah, okay, well, we shouldn't have QA teams, we shouldn't have QAs. And those roles vanished. I think we need them back. So I think someone that can look holistically at the quality of your software and can understand the right ways to verify that at the different points in the cycle. So I think those are roles that we are now going to need. And I think if you're worried about your job, this is where you spend time now because that role isn't going to go away. And so that where a role that where I've landed at is we need QAs back. That's where I'm at now.
That's very interesting take because a lot of the discussions that I've seen in the space have been revolving around using AI as a verification tool. So you have even the joke, it's turtles all the way down. It's
Yeah,
like it's LLMs all the way down
yeah.
because you generate code with LLMs, you write tests with LLMs, you put LLMs to test them. You put LLMs to write the verification. You put the LLMs to verify that the code verifies that specification, and so on and so forth. Um, do you see a breaking point there? Is it sustainable? Why do you say that QA is a potential solution to that, given the enormous amounts of code that we're going to deal with over even 6 months from now?
So I think it's about the bounds of where verification is done. So if you think about why I write a unit test, it's because I care about my code at a low level, and therefore I want fast feedback, right? We're getting to the point now where, almost the model I'm sort of thinking about is we define the boundary in which we let the AI play. And I think the human being should be involved in defining the boundary, a module boundary, a service boundary, right? We should design the interface for that because that's fundamentally about human connection. And then we let the AI play within that. So your unit of verification then becomes that unit rather than the unit being a function or an individual piece of code. But we also have to recognize is that LLMs have no fundamental notion of truth. They have no concept of truth of the world whatsoever. The reason they hallucinate is because they don't know what's real. Um, and there is a lot of work that's been done in the AI space is going back decades into things called world models, where we have AI systems that can actually sense and get feedback from the real world, from the physical world, that can understand cause and effect. I mean, neural nets do some of this stuff as well. So I think if you think about what a lot of what QA does, the QA is what humans are great at. Humans are great at sensing. They're great at predicting. They're great at understanding causality. LLMs have no sense of causality. And so I think until we have those world models either used instead of or in conjunction with the current software we've got, we have to accept that what we're getting is something that's plausibly right, but is not 100% verifiably right. So we have to verify it. So I think that's where we are at the moment. I'm not saying it's an insurmountable gap. I'm saying that there is a gap though right now, and it depends on how far you want to push it. Now, of course, we've been beneficial with coding, especially if you're using a statically typed language, is that we have the compiler, right? So already we get that feedback. Well, I'm not trusting the LM, I'm trusting the compiler. It compiled, right? And then a lot of us have test suites and we can run our test suites on it and say, so I've actually done the work to validate that it's working well. That's good. But we're now like, it's almost like we've been building a railway track underneath us, right? Out across the gorge. And we've had the benefit of our test suites that we already had, and we're changing or adapting the code. And then suddenly we're now going to be we're probably already in the period for a lot of people where we don't have that verification layer that we understand anymore. And so we're losing sight. And I think what you'll see is a lot more examples of crazy stuff only being seen by the human beings once it gets into prod, right? So um, I think there's a big gap there. And look, I know people are looking to solve it. It's also, we have to acknowledge that it's not a gap that the big AI vendors want to talk about because they have to acknowledge that LLMs aren't the only answer to this quiz.
I prepared a set of questions for your microservices work, but I wanted to tie it into our existing conversation about the verification and the testing part. And one of the particular pain points while choosing microservices as an architecture for a product is the ability to test the whole thing, like end-to-end testing, in an increasing set of services, which can very easily explode. Could you speak to that, and can you add the AI flavor of our previous conversation? How does that
Yeah.
tie into
Um,
the ability to test this particular architecture?
yeah, and this is where I think we're hitting an interesting, challenging point. I haven't yet worked out how to resolve this tension. End-to-end tests are in general expensive, well, historically have been expensive to write and would typically take a long time to run compared to, say, a unit test. And when something like that fails, we have like this called poor isolation, which just means it like because it's testing a lot of the scope of your system, like any part of that code could have failed, right? You then have this other element when you start moving into the world of microservices, which is if you start running end-to-end tests across a microservice architecture, those larger scope tests have an even greater scope. They're now encompassing multiple network hops. You're going to stand up infrastructure. And more problematic is that they start to cross team boundaries. So, you know, ideologically, and microservices is an ideology at a certain level. Microservices are about independent deployability. It's like making a set of decisions and a set of architectural trade decisions to allow services to be changed easily, independently. As you start having end-to-end tests, though, it's when they start crossing team boundaries, beyond the challenge of actually writing those tests and getting them to be useful to you, they end up becoming almost like an organizational bottleneck. Because I want to release my software, the end-to-end test isn't passing. Why is it not passing? Because that team over there broke something. Oh, okay, so do I have to wait for them to fix it? Are they going to fix it? Well, it's only broken because your code does something different. Well, whose fault is it? And then you're having a meeting, right? Anytime you have a meeting, right, productivity goes through the floor. So that's the whole problem. So in fact, actually, from the very first, one of the chapters that changed the least between the first and second edition of the books was about testing, was saying that we have to recognize end-to-end tests are problematic for microservices because of the issues I've outlined. And as a result, we should look at tests which give us, or we should look at more generally, verification mechanisms that give us confidence about our system without requiring end-to-end testing.
How do you even
So
do
you've got
that? How do you even tackle that?
there's a bunch of different ways you can do this. I mean, let's start with the things that break. Contracts break, right? People screw up the interface. They make a change that creates a breaking structural change in a service boundary. Now, again, coming back to the example of compilation of code, if I get a type signature wrong, the compiler catches that. We don't have a compiler for a distributed system, nor would we want one. So structurally, if I remove a field that was previously required and roll out a service as a backwards incompatible change that could break things in production, but I can actually catch that just by having explicit schemas for my service endpoints. And so, and then comparing versions. So if I'm using something like Avro, gRPC, for example, the proto buffer format, you can actually take, okay, I've changed my interface. Here's the old version. Here's the new version. Are they backwards compatible or not? That's a quick win. Not many people do that. You can then got things like consumer-driven contract testing, which I mentioned as well in the book. Nowadays, I mentioned originally a tool called Pact, which was the first tool that did this. The workflow wasn't great. A tool I tend to point people at now is a tool called Specmatic, which is an open source project that kind of takes this idea of schemas and builds upon it. So the idea being like my service exists to be called, you're a user of my service. Explain how you want my service to behave. You write some tests that say, here's what your service should do. And I then run those tests as part of my build. I don't need to have your actual physical service running there. You also get some side benefits that by you saying, here's how I'm going to use your service, that actually ends up being a stub for your own testing. So now you can test in isolation, I can test in isolation. And then, of course, there's all the other things that we can do to catch problems in production before users ever see them, right? You can roll out versions of software, but don't release them, then run smoke testing and shadow testing in production environments. You've then got things like canary rollouts, you've got parallel runs. There are all these kind of production rollout techniques that can allow us to spot problems before a user ever sees them. And so for me, the challenge with this is you've relied on end-to-end tests, and now here's Sam saying, don't do end-to-end tests. And the simple solution is do these 25 other things instead, right? I think the reality is the way I tend to talk about this with teams is you've got a reliance on end-to-end tests right now. Great, don't remove them. But as you go on this microservice journey, you're probably going to want to reduce your reliance on end-to-end tests and start putting some of that energy into other types of verification process. And I think all part of this as well is bridging the two worlds, which is functional automated testing is primarily verification of the quality of our software in a pre-production setting. And then once our software gets to production, we verify software in completely different ways. Often different people thinking about different sets of requirements using different sets of tools. And this is why I was coming back to the idea of the QA to an extent, is if we think a bit more holistically about where is the best place to verify our software, let's look holistically about where that verification is done. Because maybe if we're doing a bit more in the production deployment versus release process, we can do a bit less in the delivery process or vice versa. So I think you look at it as a piece. So I think that's kind of right. So that's all that stuff, right? So of course, a big driver then is how do I reduce the scope of testing? Now, when we started getting into the world of AI generated systems and verification, I think the open question for me is how much do you embrace the model effectively of having a no-go zone for developers? So in robotics, you get robots that are designed to work in a space where humans are also operating. And then you get robots where there are, if you see them in factory settings, where there are big bits of tape around them areas or physical barriers, and human beings do not interact and do not go in those spaces because that is the zone for the robots. Because it's dangerous for human beings to be there. There are terms, I wish I could remember what these terms are. And I think we're getting there with code. I think with as the capabilities are quite simple, we were writing and changing code in the same space where the coding agents were writing and changing the code. We were all kind of working around in that same space together. So we had a set of working practices that aren't necessarily working well with how the AI wants to work. But if, on the other hand, what we actually do is say, well, let's make a box. We as a human being are going to identify the need of that box for that box. Maybe we've been given some guidance that we might need that box from an AI, but we've made a decision to do it, right? Here's the box. Here's what we want the interface of that box to look like. And the reason that's important is like an API of a module or a service, that's a user interface, right? So we should design that as a human being. Think about, outside in thinking, all that other stuff. But then maybe we say to the AI, that is your box. You manage that box. I don't go in that box. So if I'm not going in that box, do I care about things like small scope unit testing? Not really, because that's talking about making my code easy to refactor, to make my code easier to understand. But I'm not trying to derive understanding of what's in that box by looking at the code anymore. I'm deriving that understanding by asking the AI what that bit of code does, or using my verification outside that box. And so I think then that probably shifts us from not needing some of those smaller scoped fast feedback tests, which are there to help us refactor and restructure code inside the box. I think we kind of, if you think about Mike Cohn's testing pyramid, right, it may be actually we just for the modules that are fully AI owned, we just drop that bottom layer off and we just deal with the bit above. These are sort of theories and patterns that I haven't fully worked out yet. I'm literally, as I'm finishing off one book, I'm in the process of planning my next book, which is going to be in this area. So it's trying to work out what those patterns are. But I do think, like that robotics model, the working practices are probably going to change for where we and the AI coding agents are working hand in glove versus where we're just going to let them handle modules. And you've got people now who are pushing the envelope here and are running, agentic code generation workflows that could be running for hours, if not days, at the bleeding edge. There's lots of technical problems with that, and we all know as well that costs way too much money. But if that is the future, then we kind of do need to, I'd say, that we're not going inside that box anymore.
What are some other evolving tools that, at least at the time that we're recording this, have made, let me just focus on the microservices architecture, uh, that have made microservices easier than, say, 5 or 10 years ago? Because microservices have been a thing for a long time, but they've only become fashionable in the last decade or so.
Yeah, yeah,
Uh,
roughly speaking. Yeah.
what are some of the tools that you've seen? So we're speaking to an audience that are mostly software developers. They work at the very ground level. Some of them are working at the higher architectural level because the senior engineers do need to have that overarching view. But my audience is, at the time we're recording this, mostly interested in programming languages, tools, frameworks, things that just make like the building blocks of the software easier. Have you seen tools that made microservices easier with that context?
Yeah, I think there's three things I can point at. The first is containerization. So when I wrote my first book on microservices in 2014, this was 2 years after it came out in 2014. This is like a year and a half after Martin James's article on microservices came out. Containers were a thing, but they were a bit niche. And what kicked them into the mainstream was the work that Docker did to standardize the container format, the container image. And then obviously things like Kubernetes becoming mature helped because that gave us a way of deploying and managing these things effectively more like a black box. Going from managing containers from managing VMs like night and day, much more efficient and much easier. The second thing is a robust set of tools around infrastructure, automation, and skills in that area. So understanding the importance of things like infrastructure as code, having a variety of different sort of declarative systems that allow us to bring infrastructure into a known state becomes really important with microservices because you can't take, you can get away with a bunch of manual operational processes when you've got one thing to deploy, but when you've got 10, 20, 50, it doesn't scale. The third thing, honestly, was the public cloud. So although lots of people run on-prem, a lot of the case studies and a lot of the examples that help kickstart and show what was possible was done on the public cloud, which is kind of bringing together again that infrastructure automation part of the puzzle together with rentable compute. When I first started my career in the sort of late 90s, there was still very much a difference between being a logical architect and a physical architect. I mean, I was a developer and a sysadmin. That's how I started off. And like the logical architect wouldn't really care, wouldn't really bother themselves too much with the underlying hardware and the infrastructure. You can't do that with microservices. You need to fundamentally, you don't need to know to the depths that I do or, hardcore Kubernetes admins or anything do necessarily, but you need to have borrow a phrase from Martin Thompson, you have a degree of mechanical sympathy for the infrastructure you're running on because the architectural decisions you make around boundaries have an impact for the operating environment and vice versa. So there does need to be a much more of an awareness of those things. And so the public cloud, I think, made that much more accessible. And, by extension, software-defined networking and things like that. So I'd say containerization, better infrastructure automation tools in the public cloud, the big three that I think drove all of this stuff forward. And then you've kind of, you cannot overestimate the importance of continuous delivery and the DevOps movement on all of that. We were looking at these architectures and started seeing these architectures. I mean, James originally spotted this pattern where he was looking at companies that were really pushing themselves to release software more frequently, to reduce their batch size, to treat every check-in like a, production-ready release. And organizations were using these types of architectures before we gave it a name. And they were doing so partly because of the lessons that the continuous delivery book and people like Jez and Dave and Pat Dubois and and a lot of the DevOps people did and shared. It opened our eyes to the art of the possible. And this, DevOps, I think Neil Ford has described microservices as the first post-DevOps architecture. And I think that's kind of right. I don't think it exists without continuous delivery and DevOps, which again, coming back to containerization, infrastructure automation, and public cloud, those are three discrete groups of technology which very much come from those worlds.
When you are hired, I'm pretty sure that a lot of teams and a lot of original projects go and start with, "Hey Sam, we want to hire you because we've decided to pick microservices," and they list you a bunch of reasons. Are there, and I'm pretty sure there are, situations in which you say, "No, no, no, you've misunderstood microservices. This is not the way to go. You're asking the wrong questions." What are some of the wrong reasons that you hear, and how do you usually push back?
Um, uh, I would reckon about most of my clients say, should we use microservices? It's a much, I like that place to start rather than we are using microservices because I would say probably about half the time I advise against microservices and I'm nearly always advising them to be much less aggressive than they're otherwise planning to be, right? Even when they do go ahead. So what are the wrong reasons? I don't think the reasons are necessarily wrong, but what often happens is sometimes what I see a lot happening is a reverse engineering of justification. People want to do microservices and they're finding reasons why. And so they'll say things like, we're going to microservices because we will need to be able to ship software more quickly, for example. And I've definitely seen microservices help organizations ship software more quickly. Absolutely have. Is that where I'd start? Because actually, if your goal, like I care about helping people around the outcome. Like if your goal is to ship software more quickly, great, that's your reason why. And I can see why microservices might be part of that. But let's just go dig into this a bit more to make sure you're going to get the benefit you expect from this change. So then I'll ask things like, have you done these other activities? Have you like done some even basic cycle time analysis? Because like even simple, because sometimes the issue can be organizational, right? If you've got 25 handoffs resulting from a software release, going to microservices isn't necessarily going to magically fix that. But if we could go from 26 handoffs to 12 handoffs, that doesn't involve any technology changes, probably, right? So for me, it's often drilling a little bit deeper. Because what I like to do is say, okay, what are you trying to achieve? Now let's think of all the things that you could do to achieve that goal and make sure we do the easy ones first. If you want to scale your system and scaling is all you care about and you're on the public cloud, have you thought about getting a bigger box? It is a deeply unsexy thing to say, but it's true, right? Now, if you have, great. Have you tried running two copies of your big box behind a load balancer, right? Because that's cheap. Do that next. Then come back to me, right? Um, and so it's not about it's delicate, right? I've definitely walked away from work without just from an initial call realizing this is not I'm not going to be able to help you achieve what you want to do in the way you want to work, right? Would be the most polite way of putting it. But it's always about that probing. And so I always try and work outcome back. So I've sometimes described microservices as being an architecture of last resort. And what I mean by that is I'm going to try the simple things, the simple ways to fix problems. And microservices are never the simple things. Microservices are what I reach for when I've tried the simple things. Um, and kind of closing the loop a little bit, that's also why I cared so much about including coverage of the organizational side of things, the people side of things in the microservices work, because if you try changing the architecture but don't change the organizational structure, you're going to set up impediments which might undermine your drive towards faster, more frequent delivery. So you kind of need to pull back a little bit and have those conversations. Those are tough, those conversations, I'm not going to lie. The
This
easier conversations actually are, we did microservices and we've ended up with a giant mess, help, because then we've got some concrete pain right in front of them that we can deal with, and you've got lessons that everyone can learn. Whereas the other stuff, I'm having to get them to trust me that these things are going to be bad for them and they haven't seen them be bad for them yet.
I love how you nuanced that answer because one of the questions that popped in my mind, having read and having tried many styles of writing code and deploying my own projects, it's really clear that microservices are not necessarily the goal, and Kubernetes is not the goal. I think there was a tweet the other day by one of the tech influencers. I forget which one it was, and the tweet said more like was more like a joke, saying, "Hey, I have 10 users now. I better use Kubernetes." That's definitely not the way to go, obviously. And the question of have you tried a bigger box definitely applies to I don't know, starting projects where you don't really need an architectural change. And there's definitely pushback from, for example, indie hackers. They just ship a piece of code and they just beef their box if they want more users. And there's this guy who makes, I think he makes millions of dollars now on PHP, and he just uses a very beefy box, just like one box. He has tons of traffic, tons of users. Uh,
Yep.
Obviously. So I love how you nuance that answer. What are some um, I want to say mathematical, but not necessarily mathematical concepts that microservices want to implement? For example, idempotency. This
Mm.
is very easy to define, but very very hard to implement. At least as far as my own practice goes, I'm working on expanding my own Rock the JVM learning platform into a larger one, and I do need something that follows a saga pattern with idempotency because I'm running some really critical flows and they need to be auditable and stuff like that. What are some examples where you saw that idempotency either breaks down or is very, very difficult to implement?
It's typically most. if we think about it at a service interaction level, like so to explain the classic problem is if I ask a service to do something and I don't get confirmation it's done it, there's two possibilities, right? The first possibility is it's done the work, but the acknowledgement got lost. The second possibility is it didn't do the work. And if I just naively say retry, I might end up doing the work twice, right? And sometimes we don't care, and sometimes we really care, right? So this is at the heart of like the whole arguments around exactly once versus more than once processing as well. The bigger challenge is often about retrofitting. So at a service API level, the easiest mechanism to implement idempotency around operations is to use something like an idempotency key, right? So you're going to you basically generate a unique UUID for that operation. You pass that through in the message you're sending. And on the server side, you store the results of the operation against that UUID. And if someone reattempts that operation, then you see that UUID is already there. You send them back the same results. You say this is what's already done, right? There's nuances there around, expiring UUIDs if you're worried about collisions, but they're actually got quite a the resolution of modern UUIDs is pretty good, so you're unlikely to have that clash. The challenge becomes is retrofitting idempotency into existing systems. That's classic what I've seen as the issue is that you've got systems which don't, sending that idempotency key, that's a key I've got to send, and that the server side has got to recognize and pick up. And what's it going to do? And so then that's by definition is going to be a backwards incompatible change. So in situations where people are dealing with legacy clients, for example, where you can't change the clients and get them to start sending an idempotency key. So there's other mechanisms you can use. That the pattern I describe it as is server-side request fingerprinting. So what you do is as you receive the operation, you basically create a fingerprint of the operation and say, this is what they're trying to do. So I'm going to create like an MD5 of that, like effectively a hash of that. You might have to do some field masking and stuff like that because might be some fields that vary. And then so rather than storing that against a UUID, you store that against the hash instead. That gets really problematic though when you get operations which look identical, which can validly be done really close to each other. So to give you like an example on AWS, I could write a line of code to spin up an EC2 instance and then do the same thing again really quickly in a for loop. That's a valid thing for me to do. On the server side, the fingerprints would look identical. I don't want them to be falsely excluded. We should both happen. That's why AWS uses idempotency keys. You can actually see this play out in the real world. I was speaking to a team in Denmark around this. It's one of the credit card systems. If you go into a shop, I'm pretty sure it was I can't remember the I won't name the payment provider just in case I get the name wrong. So you go into a shop in Denmark, you buy something, you go buy a bottle of wine, 40 kroner, great, done. And then a minute later, you go buy the same bottle of wine, 40 kroner. The second payment gets rejected by the terminal because it thinks it's identical. Now, it's not identical. I can see I'm trying to buy another bottle of wine, and that's because it's generated a hash to show that it's the same, and it keeps those hashes for about 5 minutes and then gets rid of them again. So you can, when you're retrofitting, that's where these things start to break down. In my experience, if you can think about idempotency up front as a formal part of your interface design, if you're building a services architecture anyway, then I don't think it's that difficult. I think again, picking a decent UUID, and there's some, I can't remember which version of the UUID spec. You can use really funky things with UUIDs. Like I think it's version 7 or maybe version 9, which is time sortable, for example, which makes things beneficial. There's others that allow you to put custom data into those UUIDs. And the key thing about these are like you might retry an operation more than once. So each retry would be the same key that you're sending through. And these would be different to span IDs and different to trace IDs that you might have as part of your observability pipelines. I mean, the little tip I'd give to you as well is just if you're looking at implementing Saga patterns, I would just take a look at Temporal because it's pretty good. Like it's really good.
Nice.
As a platform that does a great job, I think, of making it easier to implement as a lightweight framework for implementing workflow. It's almost my plutonic ideal because I've found a lot of the other workflow stuff I've looked at to be quite heavyweight. there's that old adage that, you call a library, but a framework calls you, and it can be quite invasive. Whereas it's just you write some code, you stick an annotation on it, you point temporal at it, and it kind of works it out, and it makes sure the flows actually happen. You still need to do the work around the idempotency within your own operations, though, of course. But I would at least look at that rather than hand rolling your own durable workflow system.
Nice. And I wanted to be respectful of your time, so I won't keep you for much longer. I do want to come back to a bookmark that I left in the middle of the conversation, which is a note on what you said about PRs not being the what do you call it, the preferred way of, or the ideal way of shipping code in a large organization because it was originally designed for open source. Can you expand on that? And
Yeah,
what are your takes on the let's say general Git flow?
yeah. Git flow's terrible. I'm very happy to be. I've got a whole ranty. It's one of the most ranty talks I've done, talking about software branching in the post GitHub world. You can find it on my website. So the PR process was originally much simpler than the Git flow process, which is a really overcomplicated version of this as well. But it's fundamentally based on the premise of untrusted committers. So in an open source environment, you have core committers that have commit rights. They're trusted. And then you have other people who aren't trusted. And they send you a PR. And they are often working a few hours here, a few hours there overnight. They're not working they're not working full time on this project. You then get those things in, you go through them, there's a bit of interaction, and then you merge the change in or not, as the case may be. That pattern of how open source software delivery works is not like how we do software design as professionals. Virtually everybody is a trusted committer to some extent, working kind of more closely together. So adding this ceremony that actually just lengthens the merge process and puts more bureaucracy around the merge process is really problematic. Because the problem with a lot of PR organizations that have adopted PRs is they don't realize they're basically dealing with long-lived branches a lot of the time. Now, if you're merging your PRs if you're merging multiple PRs a day, then fine. But if you're merging, like as an individual, you're creating and merging multiple PRs a day, fine. But then you don't actually need PRs. You just go straight to trunk-based development, and you'll be happier, and you'll be better looking. Your loved ones will think you're better and more handsome, right? So I think the problem fundamentally with me is that the PR process doesn't actually always encourage a proper review of code and actually lengthens how long code lives on these branches for. Fast, integration of code is essential. I mean, let's talk about tenants. Most people don't understand continuous integration, right? If you go back to the original continuous integration definition, it's like you should be merging your code with mainline at least once a day. And the problem with people started to understand that long-lived like release branches or feature branches were bad. We understood that process. And part of it we knew was bad because Subversion and before that CVS made branching so painful anyway. We sort of had this awful friction. Git came along, made branching cheap and quick and easy, and we seem to have missed that lesson. And then the PR process made us pretend that we weren't doing feature branching again. So to an extent, I blame Linus for this. But there's also like ideologically, right? Git was a source control system designed for not just open source development, but a specific type of open source development, being the Linux kernel. So it's massively overcomplicated for what we actually need as well. So we've got all these other things going on. But it is sort of interesting, right? So I still believe that the best way to develop software is to do trunk-based development. I still love pair programming. That's still my happy place, but I know it's not for everybody. But I don't think the PR process necessarily helps that whole process. I mean, there are hybrid models. So I spent like about a year and a half working at Google in the tools team, and that was really then, and so I got to see firsthand how the system there works. They have trunk-based development in Google, but they do have a PR process as part of that. But it's very different and much more streamlined compared to say how the processes work around Git flow and everything else. Although, again, you shouldn't copy what Google do ever. Not saying what they do is bad, but you're not Google. It's a weird place to work.
You're not Google. I think that's an excellent place to wrap up this conversation. Sam, it's been a pleasure. Thank you so much for making the time. I'm going to leave a structure of the conversation in the description because we've covered a lot of ground. I wanted to tell you that I'm grateful for the time that you've made for this conversation. And before we wrap up, I wondered if you had any thoughts or any tips, or if you want to leave just a thought to this audience of software engineers.
The whole world's losing its mind on many different axes. Um, AI is changing how we build software, but I think anyone that tells you that they know how it's changing how we're building software, they've got no idea. I think you just need to keep your head down and stay employable until everything calms down a little bit. And so my only advice would be to don't believe you know exactly what's going to happen next. Stay curious and yeah, just roll with the punches. It's going to be a hectic time for all of us, but it will come out the other side.
Awesome. Sam, it's been a pleasure. Thank you so much for making the time. And for everyone else, thank you for listening.
Thank you so much.